Hello. In this video, I'm going to explain what it means to scale an image. Oftentimes, scale is used in drawings that are done by architects and engineers in order to represent objects from the real world in blueprints or plans. There's two different kinds of scaling. We can use the principle of scale factor to enlarge or to reduce an image while maintaining the proportions. So very simply, what that means is if you are applying a scale factor, you are keeping the shapes the same, you are keeping the relative sizes of the components of the image the same, but you may be zooming in or zooming out. So if you're going from a smaller version of something like this word scale, and you are zooming in, making it appear larger, then that's going to be described as scaling up. Also an enlargement. And in this case, if I look, for example, the height of these letters has gone from 2.2, so I started at 1.1 centimeters high for this S, and now it is 2.2 centimeters high for this S. And the same applies to each of the letters. So the scale factor for this growth from the smaller version of the word to the larger version of the word is a factor of 2. I've doubled the height of each of the letters. If I were to verify with the width, it is also double. So I've gone from about 0.6 to 1.2 as the width. So the width of each letter has been doubled, the height of each letter has been doubled. I could also describe this as a 200% enlargement. If I were to consider that the scale is going the opposite direction, I'm starting with the larger image and I am shrinking it down, then this would be described as scaling down from larger to smaller. And because each letter would be then going half of its size, the scale factor is going to be 0.5, also considered a 50% reduction. Now we're going to look at an application of scale factor. So in this scenario, the story that we're going to be working with is Mika, who is planning her wedding, is working with a room that is 42 feet by 60 feet. Like this. Okay, one tick mark is feet. And she's decided, in order to lay out the placement of the tables in this room, that she's going to use grid paper just to keep it organized and neat. But the problem is that the paper doesn't contain 42 squares and 60 squares. So there's not the ability for her to use a 1-to-1 scale on this paper. So looking at the number of squares that are available, she decides that she should be able to reduce it by a ratio of 1 to 2. So I'm going to write that down here. okay, meaning that one square on this piece of paper is actually 2 feet in real life. So in that case, the rectangle that she's going to draw to show the boundaries of this room is not going to be 42 by 60. It's going to be 21 squares by 30 squares, half of each of those values. Now, this grid paper is 1/4 inch grid paper. So I could start counting 30 little squares, but I don't have to do that because I know that every inch on this grid paper, so here's 1 inch, contains 4 squares. So I can count by inches, and then that will be counting by 4 squares. So 4, 8, 12, 16, and I've got 4, 8, 12, that's 28, 29, 30, right there. So that's 30. And then across the top here, I need to go 21. So again, I'm going to be using my grid here. So 4, 12, 16, 20, 21, right there. So now I've got a rectangle that represents the room that Mika has to work with. Partway there. Now, the banquet hall that she's going to be renting has several different tables to choose from, and she's got to decide how to lay them out in the room, how to position them in the room. And here's what they're going to look like. So one of the table choices that she has to choose from is a square table like this. And I'm drawing this to scale using the same scale. So the center here is not usable space. Perhaps you could put spices or something on it, salt and pepper and whatever, but no one can sit there, for example. So in this particular table selection, you would end up with chairs around the outside like this. That allows 2 feet for each person to pull up a chair. Okay, and there's nobody sitting on the corners. So you can figure out how many people would be able to sit at that size table. There is another table design that she has to choose from where the non-usable space in the center, where people cannot sit, is a little square like that, 2 by 2. And this is the table around the outside. And people can be seated around the edges like this. Again, no one sits on the corners here, but they can sit here. So you can figure out how many people would be able to sit at that table. And I need to leave a little bit more space. The third possible size of table is with a little square that is 3 by 3 in the middle. So this is not usable space. Okay. And you should be able to figure out how many people could be seated around this large square table. So here's what your challenge is. You have to figure out how many people she can fit in this room, given several limitations on the space. So one of the limitations on the space is that in between the seating area, in between one chair and the chairs of the table next to it, you have to have 2 spaces like this so that there's room for those chairs to be pulled out without people getting in each other's way. So this example that I've got here on the bottom, where they're 2 apart, that's good. Okay, this example here where they're only 1 square apart, that's not good. Okay, so that would not meet the requirements. Too close. The second limitation is the tables have to be at least 1 space from the wall. Okay, so for example, this chair, there's a space and then the wall. This one, there's 2 spaces and then the wall, so it's fine. So the reason that limitation, you can imagine, if it was too close to the wall and the chair was tucked in there, you wouldn't be able to pull the chair out and actually sit down. So your job is to figure out how many guests can be seated in this room. And you can play around. You can actually increase the size of the tables up to a maximum of a 7 by 7 square inside. Okay, so the non-usable space here, I've got a 1 by 1, 2 by 2, 3 by 3. You can go all the way up to a 7 by 7 square on the inside and then go from there. So I'm going to do one example of, say, a 6 by 6. Let's say the table is right here in the corner. Okay, so 6 by 6, this is my non-usable space inside. And then my table space, or surface wraps around that. So this is all the table. And then from there I can figure out my chair placement. Okay, like that. And if I were to place another table, I need to leave 2 spaces, and the chairs would have to go in this row here, in this column here. Okay, so your job is to figure out what's the maximum number of people that can be fit in this room using this scale. Good luck.